Module 2: Waste Management and Circular Economy. What is waste management? Waste management, in its simplest terms, is the collection, transportation, and disposal of garbage, sewage, and other waste products. The process of waste management involves treating solid and liquid waste, and during this treatment, it also offers a variety of solutions for recycling items that aren't categorized as trash. In this module, you will understand waste generation trends and the magnitude of waste management challenges, particularly in sub-Saharan Africa. Identify challenges presented by waste generation and the waste management process. Describe the principles of a circular economy and its hierarchical order within the waste management hierarchy, focusing on waste prevention, reduction, reuse, recycling, recovery, and disposal. Explore entrepreneurial opportunities in the waste management and circular economy sector, drawing inspiration from real-world case studies in Kenya, Ghana, and Nigeria. Be well prepared to contribute to environmental sustainability and seize entrepreneurial prospects within the circular economy. Introduction to Waste Management and the Circular Economy. In 2012, Africa generated a total of 125 million tons of municipal solid waste MSW, with sub-Saharan Africa contributing 81 million tons of the total. The average composition of MSW in Africa comprises approximately 57% organic waste, 9% paper or cardboard, 13% plastic, 4% glass, 4% metal, and 13% other materials. The composition of MSW in Africa varies based on factors such as consumer attitudes, income levels, and cultural practices, leading to regional differences which present challenges and opportunities for sustainable development. Concerns over waste include health and safety concerns. Pollution is a current concern: water, land, soil. Conservation of natural resources, pollution control, recycling. These issues are important to achieve sustainable development which meets the needs of the present without compromising the ability of future generations to meet their own needs. Solid waste characterization. Determining the quantity, composition, physical, and chemical characteristics of the waste is important. 1. To enable design and operation of all elements of waste management at primary storage facilities, frequency of collection, treatment, and disposal methods. 2. To carry out recycling, the recyclable components in the waste stream will be of interest. 3. For treatment by incineration, caloric value, bulk density, and moisture will be of interest. Principles of waste management include polluter pay principle, from cradle to grave, the waste hierarchy, integrated waste management, and finally, integrated sustainable waste management, the waste hierarchy, from the most favored option to the least favored we have. Prevention, minimization, reuse, recycling or upcycling, energy recovery, disposal. The integrated waste management. Integrated waste management involves materials recycling, landfill, thermal treatment, biological treatment. Then for energy recovery, we have landfill gas use, mass burn, fuel burn, biogasification. With all these processes deepening on collection and sorting. Integrated sustainable waste management. Here, stakeholders meet aspects of waste management, use proper waste system elements, and produce sustainability in process time. Principles of circular economy. The systematic order of managing waste is referred to as the principles of a circular economy. These principles are based on 5 priorities: refuse, reform, reduce, reuse, recycle, and produces a destination with minimum waste. Recycling technologies and processes. recycling involves a collection of recyclable materials, manufacturing or reprocessing this material into new products, then the purchase or sale of these products. Chemical recycling. Chemical recycling is the process of breaking down tough plastics into their original forms, known as virgin equivalent plastic. Two methods are used for chemical recycling: closed-loop recycling process and decomposition. Both methods break down polymers into smaller molecules or monomers that can be used to create new recycled plastics and other chemicals. Solvents are used to separate the polymers from additives or contaminants, leaving pure recycled plastic in the end. Mechanical recycling. Mechanical recycling converts plastic waste into secondary plastic material without altering its original chemical structure. This method works for thermoplastics and is one of the most common methods used for recycling plastics. The steps involved in mechanical recycling include collection of end-of-life plastic products, sorting of plastic waste in terms of color or thickness, shredding of plastic waste into smaller pieces, washing to remove dust or dirt, second sorting of plastics before extrusion, and extrusion that turns plastic flakes into uniform pellets ready for manufacturing new products. Mechanical recycling is cost-effective, reduces the amount of plastic waste that ends up in landfills and oceans, and helps conserve non-renewable resources as it uses plastic waste to create new products. Dissolution recycling. Dissolution recycling is all about separating polymers from plastic waste so they can revert to their original chemical form. These polymers are broken down into high-quality monomers, which can then be used to create new polymers with the same properties as the original materials. Organic recycling. Organic recycling involves the controlled treatment of biodegradable plastics through composting or biogasification under specific conditions. In composting, the organic waste goes back to the soil, acting as a natural fertilizer for new crops. When the recycling happens under anaerobic conditions, the energy produced is typically used for various purposes. Monomer recycling. Monomer recycling or depolymerization is a recycling method where the long polymer molecules in plastic are cracked into monomer building blocks, which are then used to create new virgin plastic materials with identical properties. This kind of recycling stabilizes the recycled plastic, making it more durable for future use. Recycling waste internet. Recycling businesses are now leveraging the power of IoT-enabled waste management techniques to streamline their operations. With fill-level sensors, smart bins, and material quality assessment sensors, they can track and manage waste more efficiently, minimizing inefficiencies in waste logistics. Recycling robots. These are AI-powered sorting systems that help automate and enhance sorting lines, increasing speed and accuracy while reducing errors and operational expenses at materials recovery facilities. Waste heat valorization. This involves converting waste into energy sources or chemicals without compromising material quality. Anaerobic digesters are used to treat organic waste and generate biogas, meeting the rising demand for clean energy solutions. Artificial intelligence. AI integration in recycling practices enhances recycling efficiencies by automating material analysis, sorting, and other tasks, minimizing human exposure to hazardous waste streams, and improving overall productivity and operational scalability. Other tech solutions. Other recycling technologies, such as automated route optimization software and cloud-based waste management software, help streamline waste management operations and improve overall operational efficiency. These advanced recycling technologies are revolutionizing the recycling industry and paving the way for a more sustainable future. Business opportunities in waste management and circular economy. Africa's circular economy presents a wide range of opportunities across sectors, promoting resource efficiency, waste reduction, and sustainability. From tackling plastic waste through recycling infrastructure and sustainable packaging to capitalizing on the growing demand for electrical and electronic equipment with e-waste collection and refurbishment services, businesses can find lucrative pathways. E-waste management services. With the rise of digital devices, there is growing concern about electronic waste management. Businesses can establish e-waste recycling facilities, provide e-waste collection and disposal services, and promote responsible disposal and recycling practices to minimize the environmental impact of electronic devices. Technology for waste services. Green entrepreneurs can investigate developing technology that would aid waste management and disposal. An example is the creation of digital waste management platforms or mobile applications that facilitate waste management. These platforms can connect consumers, businesses, and waste recycling centers, making waste management efficient. Waste equipment providers. Waste equipment provision involves supplying a range of tools, machinery, and systems necessary for the efficient collection, sorting, transportation, treatment, and disposal of waste. Green entrepreneurs can establish themselves as key players in the waste equipment market by manufacturing or supplying both residential and industrial waste management equipment to those who need it. E-waste collection and recycling. Establishing collection centers or partnering with existing recycling facilities to gather and recycle electronic waste safely and in an environmentally friendly manner. Activities include dismantling, separating, and recovering valuable materials from electronic devices. Vehicle recycling and parts reuse. Establishing vehicle recycling facilities to dismantle and recycle end-of-life vehicles. Operations include recovering valuable materials such as metals and plastics and refurbishing and reusing functional parts for resale. Agricultural waste management. Developing innovative solutions for managing agricultural waste, such as composting facilities and biogas production, provides both environmental and economic benefits. Businesses can explore opportunities to turn agricultural waste into valuable products, such as organic fertilizers and renewable energy. Sustainable packaging providers. Packaging is now being made sustainable by using recycled cardboard, cornstarch peanuts, containers made from mushrooms or seaweed, biodegradable and recycled plastics, minimal reusable mailers, etc. As a sustainable packaging provider, you would be opportune to work across various industries, from food and beverage to cosmetics and electronics, playing a critical role in reducing the ecological footprint of packaging and promoting sustainable consumption patterns. Plastic waste services. Africa's plastic production and consumption are rapidly increasing due to urbanization, leading to more pollution. The plastic waste crisis presents significant business opportunities in waste management. There is a clear demand for innovative recycling solutions and sustainable practices to mitigate the impact of plastic pollution. Biomedical waste services. According to the position statement by the United Nations World Health Organization, in 2000 the improper treatment of medical waste caused hepatitis B, 21 million hepatitis B infections, 2 million hepatitis C infections, and 260,000 HIV infections. There is a need for appropriate medical waste disposal. The waste from veterinary medical waste, pharmacies, hospitals, long-term care providers, and biotech or research labs are heavily contaminated, and green entrepreneurs can find opportunities to safely dispose of this waste. Hazardous waste services. Hazardous wastes can take the form of solids, liquids, sludges, or contained gases, and they are generated primarily by chemical production, manufacturing, and other industrial activities. Green entrepreneurs can take to exploring the various forms of hazardous waste management methods. Chemical, thermal, and biological hazardous waste treatment methods change the molecular form of the waste material, making it safer for disposal, while the physical treatment, on the other hand, concentrates, solidifies, or reduces the volume of the waste. Sanitation solutions and technologies. Sustainable and affordable sanitation solutions that prioritize resource recovery are crucial for safe and hygienic sanitation facilities. These solutions can reduce environmental impact and create valuable resources. Opportunities in sanitation include developing innovative toilet systems, decentralized sanitation, wastewater treatment, fecal sludge management, and waste management solutions. Investing in research and development can improve the lives of millions. Integrated solid waste services. Integrated solid waste management involves sustainable management of all aspects of solid waste, from generation to disposal, with a focus on maximizing resource use efficiency. Waste can be viewed as a business opportunity for green entrepreneurs to extract valuable resources through collection, transportation, sorting, treatment, recovery, and disposal of non-recyclable waste elements. Circularity in the fashion industry. Sub-Saharan Africa's fashion industry is worth $31 billion with 5% annual growth. Circular business models include sustainable sourcing, recycling, rental models, and consumer education. These models promote product reuse, repair, and recycling. Wastewater treatment services. There are numerous opportunities to recover valuable resources from wastewater, such as energy, nutrients, and biofuels. These involve implementing innovative technologies like anaerobic digestion, bioenergy generation, and nutrient recovery systems to extract value from wastewater while reducing environmental impact. Refurbishment and repair services. Providing repair and refurbishment services for electronic or automobile devices, extending their lifespan and reducing the need for new products. Service opportunities include repairing and upgrading smartphones, laptops, and other electronic devices to promote reuse and minimize electronic waste, restoring used automotive components and parts to their original condition. Circular business models. Develop innovative business models that promote circularity in the electronics or technology industry, such as leasing or subscription services, where customers can access electronic devices without owning them outright. The circular economy offers huge prospects for businesses to key into ventures in resource efficiency, waste management, and recycling, leading to economic, social, and environmental benefits. To truly deepen your understanding, we highly recommend exploring the case studies provided as part of this module. They offer real-world insights and practical applications of the waste management techniques and eco-friendly green entrepreneurship covered. Additionally, don't miss the training assessment attached to this module. Excited to see you shine in the next module where we will dive into the concepts of gender and entrepreneurship. Please ensure to complete the multi-choice questions before moving to the next module.